Hi guys, welcome back to Topic 5 Calculus in the Math HL course. Today we're going to be looking at some more complex differentiation and learning some of the differentiation rules. So firstly, let's take a look at differentiating with negative powers. Now this can seem like quite a simple concept, but people tend to make a lot of mistakes on what I like to call the second big step of differentiation. So let's do a little quick recap on what we learned in the previous video on how we differentiate. Our first main step, as I like to call it, is multiplying the exponent and the coefficient, remembering that this is the exponent and this is our coefficient. And the second step is to subtract 1 from the exponent, just like that. So let's do this example. So let's first multiply 5 and negative 3, we get negative 15x, and this is where people tend to make their mistake, is when they subtract 1 from the exponent. When you have a negative number, when you subtract 1 from it, it becomes more negative. So in this case, negative 3 subtract 1 will give you negative 4. As an HLAI student or as an SLAI student, you have access to your calculator at all times, so feel free to just put the numbers in to make sure that you get it correct if you feel like you're second guessing yourself. It's better to be safe than sorry. Okay, moving on, let's differentiate with some fractions. This might seem a bit foreign, but it's important to wrap your head around how this works too. So same concept as before, we multiply the exponent and the coefficient. In this case, our coefficient is 1. 1 multiplied by 1/8 is 1/8 x, and when we subtract 1 from 1/8, it is negative 7/8. Personally, despite the fact this is quite an easy calculation, I always put this in my calculator to double check because you don't want to make mistakes on these very simple differentials. Okay, moving on, we're going to look at differentiating with roots. Now this may seem quite daunting, but it's important to know that you can rewrite a root as x to the power of a fraction. So the square root of x is x to the power of a half. This is coming from laws of indices. We learn these. It's important to learn these off by heart as well. So square root of x can be written as x to the half, and now it is much easier to differentiate. We multiply our exponent and our coefficient. We have a half x, and then a half subtract 1 is negative a half. That's our final answer. You can leave it just like that. It is perfectly fine. It's correct. Okay, moving on, we're going to go ahead and look at some of the rules of differentiation. Now, I've written all of these out, but they are given in your formula booklet. I still feel it's important that you understand what they are because you'll be using them a lot in exam questions. So firstly, the derivative of e of x to the power of x remains e to the power of x. So, for example, if our x was 3, e to the power of 3, when we differentiate that, it will still be e to the power of 3. It remains the exact same. The derivative of ln of x is 1 over x. So if I had ln of 2, the derivative would be 1 over 2, or a half. Sine x, the derivative of sine x is cos x. The derivative of cos x is negative sine x. And the derivative of tan x is 1 over cos squared x. Now these are all given in your formula booklet, like I said, but they will definitely help you more on the examples I'm about to give you of some of the rules that you have to memorize, like I've written here, not given in your formula booklet. So firstly, looking at e to the power of f of x, I'm just going to write out the rule here and then I'll explain it with an example. So e to the power of f of x, the differential of that is e to the power of f of x multiplied by f dash of x, so the derivative of the function. This is all involving functions. These are not given in your formula booklet. Okay, to make this easier to visualize, let's take an example. So let's say I had e to the power of 2x squared plus 3, and I wanted to find the derivative. So the very first thing I would do is separate your function and quickly find the derivative of your function, so f dash of x. F dash of x in this case would be, so 2 multiplied by 2, we get 4x, subtract 1 from the exponent, becomes 1, plus 3, the constant cancels out. So that here is your f dash of x, that's your derivative. So now, using this rule, our final differentiated function would be e to the power of 2x squared plus 3 multiplied by 4x, in which we can rewrite as 4x e to the power of 2x squared plus 3. Okay, now taking a look at ln f of x, our differential will become 1 over x, f of x, remember it's a function, multiplied by f dash of x. And that can be rewritten as f dash of x over f of x. So that's the rule there that I would remember. But as you can see, we are implementing some of the rules that are in your formula booklet that we have touched on above, remembering that the derivative of ln of x is 1 over x. Our derivative of ln f of x is 1 over f of x, 1 over x, you can see here, and then we multiply by the derivative of the function. You can see a trend here. This is going to follow through all of the ones that I'm going to touch on. Okay, sine f of x. When we differentiate that, we get cos f of x. I've just drawn the extra brackets here so that it's very easy to see. And then we multiply by f dash of x. So I'm going to put this one in an example as well. So let's say I had sine 2x squared plus 4x plus 3. Just a nice quadratic there. Firstly, let's remove our function here and let's find the derivative of it. So f dash of x equals 2 times by 2, 4x plus 4, and then the constant cancels out. So then we can rewrite this, making sure that we differentiate the sign. The sign becomes cos. This remains the same, 2x squared plus 4x plus 3, but then we make sure to multiply by f dash of x, and that is 4x plus 4. You can rewrite that now as 4x plus 4 cos 2x squared plus 4x plus 3. Now I'm going to be very honest with you guys here. The step that I tend to once in a while forget to do is to actually differentiate here our sign and make sure that we rewrite it as cos, because I get so caught up in differentiating the function that I forget to do this, and you do not want to forget to do that because we are doing differentiation of sine f of x, not just f of x. Okay, looking down below, we have cos f of x to now do. I'm going to write out the rule here. When we differentiate cos f of x, we get negative sine f of x multiplied by f dash of x. I'm not going to do an example for this because I'm pretty sure you can kind of get the gist. It's the exact same as this, using our rules that are given in the formula booklet, and we are multiplying by the derivative of the function that is given here. And lastly, for tan f of x, we get 1 over cos squared f of x multiplied by f dash of x. Just put those in brackets here. A bit neater. There we go. And yeah, so all of these rules I would recommend memorizing. You can do these examples with chain rule, which I will introduce and teach in the next lesson. But in my opinion, learning these rules off by heart saves you a lot of time in the exam because chain rule is a series of steps and it can be time consuming. And I think that you're less likely to make mistakes if you just learn the rules off by heart. Then you can really, really quickly find their derivatives and continue with your question. I'm lastly gonna very quickly touch on something that I think is important as well, because students can sometimes get a little bit freaked out when they see there's a number in front of, for example, let's look at cos f of x. So let me give a quick example here and show you what you would do. Okay, let's take a quick look at this example here. So as you can see, we have now a number in front of the cos. What we're going to do is we're going to remove it. Firstly, we have to understand that 3 cos is basically saying 3 times by cos. So we're just going to separate it for now, and then we're going to sub it back in at the very end. So let's put the 3 and let's draw some brackets. We have cos x to the negative 3 plus 5x squared. And now we just do exactly what we would do if we just had a normal cos with no coefficient. So let's take our function here and let's differentiate it, finding f dash of x. So remembering from before, when we have a negative power, we follow the same steps as we would usually, but we just make sure to be extra careful when we subtract 1 from the exponent. So negative 3 times by the 1 in front of the x would be negative 3x. Subtracting 1 from negative 3 gives us negative 4, and then plus 10x. So that is our f of dash of x. Now, making sure that we differentiate the cost becomes negative sine x to the minus 3 plus 5x squared, and then multiplied by f dash of x, 3x to the minus 4 plus 10x, just like that. Now, most importantly, make sure that we sub in our coefficient once more. I'm just going to rearrange this one more time before we sub in the coefficient. And yeah. Now we have negative 3x to the negative 4 plus 10x sine x to the negative 3 plus 5x squared. And then subbing back our 3, we have negative 3x to the minus 4 plus 10x sine x to the minus 3 plus 5x squared. And that is your final answer. Just quickly going to make sure that I've implemented all of this correctly. Okay, let's not forget the negative sign in all of these here. That would be really bad. That is our final answer now. Okay guys, like I said, we can do all of these with chain rule, but in my opinion, it is most efficient to learn these off by heart so that you can save time in your exam. Anyways, thank you so much for watching.